Good evening to all. Welcome to the fifth day session. And this session is also an hands-on session which covers end-to-end decentralized applications using Ganeshi, Truffle, Solidity, and Python. And this session again, the resource person is Mr. Madhu Parvathaneni. He's completed his BTech and MTech in ECE and Embedded Systems in 2010 from BVRIT Narsapur. And he became an entrepreneur from 2010, starting with Orange Research Labs as CEO. After that, he maintained Mad Blocks as a director, and present he is CEO of Make Skill, and he is a mentor and entrepreneur. And present he is a certified blockchain developer, and associate had a strong hands-on expertise on Ethereum, Truffle, Ganeshi, multi-chain, Hyperledger Fabric, Stellar, Corda. And he also expertise in Internet of Things, blockchain, artificial intelligence, machine learning, embedded systems, cloud computing, virtual and augmented reality, and game development. And his work experience is he is a tech strategist for 7 startups on IoT and drones, mentor for Atal Tinkering Labs Niti Ayog, and trained and mentored more than 18,000 students, and trained and mentored more than 5,000 faculties, conducted 500 workshops or boot camps, and visited 100 plus colleges across India, and conducted 50 faculty development programs, and part of IoT Council United Kingdom, and part of IoT Software Group Singapore, and certified by RCSA Canada, and certified by IRC Japan, certified blockchain developer expert. And his associations is continuous towards MSME Telangana chapter, and COW Telangana chapter, and Palles Ruchina Innovation Trust, and Task Government of Telangana, and HISIA Hyderabad, and T-Hub India's largest incubator center, and Call for Code Global Initiative of IBM Foundation. And present he is taking this hands-on training section, and definitely assure that this section will extremely helpful to all the faculty members to enhance and to enrich the knowledge towards this blockchain technology. Thank you all. And I request Mr. Madhu Parvathaneni to take over this session.
Okay, ma'am. Thank you. Am I audible?
Yeah.
So very good evening, everyone. I hope my voice is audible and my screen is also visible. So welcome to day 5. And today I'm going to have a session on building decentralized application on blockchain. On blockchain using Truffle, Ganache, and the other programming language stack. So without any delay, let's get started. So yesterday we have created a folder on desktop, right? So I'll share this files on Git, okay? So maybe it may help you to practice on your laptops as well. Okay, give me a minute. I'll just create a repository on Git. So I'm trying to push the yesterday's code, okay, so that some people are messaging me on WhatsApp asking me to push the code. So I'm just pushing it. Okay, now it is available on my Git. So this is the yesterday's code which I have pushed to my GitHub profile. Okay, so I'll create one more branch. Say something like day 5. Okay, so to day 5 I'll just add the content. Okay, today I'm going to show you how to create a decentralized application. So yesterday I've shown you uh, how to create smart contract on Ganache, and also I've shown you how to migrate it and how to test smart contract by using Python. And today I'm going to show you how to create a decentralized application by on Ethereum blockchain network. So let me also enter into that folder. Okay, so let's start. So what is decentralized application? Decentralized application is nothing but the application which is running on blockchain network. Okay. So if the application is running on blockchain network, then that particular application is called decentralized, because in blockchain you'll have a decentralized and distributed ledger, right? So decentralized is nothing but you'll have multiple peer-to-peers. So you'll have multiple peers who are maintaining the network. If one peer, say for example, I have a peer who is maintaining the blockchain network at Vijayawada. I have a second peer which is available at Guntur who is maintaining the blockchain network. Say I have one more peer which is available at Bapatla who is maintaining the blockchain network. If one peer goes down, say for example, Vijayawada has some problem and he is down, then immediately I can connect with Guntur. I can connect with Guntur. I can do whatever I want from the application side, because every peer will be having distributed data, right? So every peer will have same kind of data, because your data is getting shared between the parties, so between the peers in the network. So that is what decentralized is. So there is no central authority. So generally if you look at centralized applications, So centralized application, if the central server is down, then obviously your applications cannot will not work for that central server, right? If the central server is down. But whenever you go for decentralized mechanisms, if one server goes down, so you'll have a different server which is running in parallel at different place. So you can connect to that different server, second server which is running at Guntur, and you can do whatever you want, though the Vijayawada server is down. So that is what decentralized mechanism is. So the same kind of decentralized mechanism will be distributed on the blockchain network. And if an application is created, say if you want to create a web application, if you want to create a website, okay, so web application particularly, and if you want to run that web application on the blockchain network, it is called decentralized application is called DApp. So DApp is nothing but decentralized application which is running on blockchain network. So the application which runs on blockchain network are called decentralized applications, which is nothing but DApp. So here I will be showing you how to create a DApp on the blockchain network, particularly Ganache. Okay, so I have a Ganache. Yesterday also I have used Ganache, right? I have introduced what is Ganache. Ganache is a local Ethereum blockchain network. It is used to have a blockchain in our laptop. You can run blockchain server on our laptop easily by using Ganache. Ganache is a local Ethereum blockchain network. And yesterday also we have deployed some contracts onto this Ganache, like block 1, block 2, block 3, block 4. So these contracts have been created. I mean, yesterday we have created a contract which stores the messages, right? So yesterday, if you remember, we have stored the messages, right? So we have stored the messages in the smart contract, and that smart contract we have migrated onto the Ganache, and the messages are getting stored. Okay, now for this smart contract, I'll show you what is the application that we have to create. Okay, so for example, say my DApp is nothing but chatterbox. Okay, so I'll create I'll use the same files. Okay, so yesterday also I've created some smart contracts, right? So I'll use the same files. I'll just put it in day5 folder. So here I have a contract. So this is a contract which stores the messages, okay, which stores the messages. So here, if you see, I have insert message function, I have view messages function. Insert message function is nothing but inserting message into the into the blockchain, and view messages is nothing but it is having a written variable which returns the messages. So like this, yesterday we have created two contract functions, insert message and view messages. And we have created a migration script which migrates this particular contract onto the Ganache. And we have written some test programs also. Okay, so this test programs, what it will do, it will try to connect with Ganache, it will try to connect with RPC server, and it will try to connect with the default account. The account value is 0, and it will try to load the ABI, application binary interface, and also the contract address, so that you can connect easily with contract by using this particular script, isn't it? So I have shown you how to how to get the data, how to insert messages and all that, right? So now what I'll do is I'll simply continue from there. I'll create an SRC folder. I'm trying to create a website. Okay, I'm trying to create a website which runs on blockchain network. So I'll create an SRC folder. In SRC folder, I'll create templates folders. So templates folder is nothing but where you can hold some HTML files. Okay, so I'll create some HTML files, index.html. Okay, something like this. Here I'll write some HTML code. Okay, so this HTML code is nothing but you will be developing some application, right? So the application which is nothing but chatterbox. Okay, so which is nothing but chatterbox, and body, I'll be focusing on body. Okay, the body is nothing but collecting the message from user. I'll be creating some kind of bootstrap. I can use bootstrap framework here. Bootstrap is nothing but simple CSS, right? So I can use some kind of bootstrap. So I'll show you what is bootstrap. So bootstrap is nothing but predefined predefined CSS. Okay, so or else if you search for bootstrap, so you'll be getting a predefined CSS style sheets. Okay, so bootstrap is nothing but free and open source CSS framework. So we can directly use this Bootstrap from the content delivery networks from CDN directly. So in W3 schools, you will have tutorials related to Bootstrap. Okay. So Bootstrap is nothing but, it's an open source CSS framework which supports both laptop, tablet PCs and mobile phones also. Okay. So for example, if you take this syntax, okay. So now if you see there is some web page here, right? So if you want to design this web page by using custom CSS, you have to define the CSS from scratch, and you have to define it for both laptop, tablet, and just mobile phone. But here by using Bootstrap, it will automatically customize everything, and it will be similarly it will be opening on mobile. So with the mobile width and mobile height, it will try to automatically open on your mobile. The HTML files will be automatically styled. So I'll be using this CDNs, which is nothing but content delivery networks. So I'll be using this Bootstrap files automatically loaded from from any Bootstrap website. I can hold it here, I can paste it here, and now I can simply create an HTML form. Okay, I can put some heading for the decentralized application. What I'm doing is I'm trying to create a front end for the application. Okay, because a decentralized application, any application you take, you'll have front end and back end. Front end, I'm using HTML Bootstrap for designing the front end. Back end is nothing but blockchain. Yesterday we have deployed the smart contracts, right? So this front end will be communicating with back end by using the decentralized approach. So here, what I'll do is I'll simply keep heading in the center. So I'll create a container, and I'll just write div class equal to container and div, and I'll put some heading. Okay, h1 starter box demo. Okay, starter box demo. So here what I'll do is I'll simply create a full stack approach for this application. I'll create a Python file which is called app.py. I'll import some Flask framework. So Flask framework is nothing but web framework which is used to connect HTML and Python. So I'll be importing this Flask, and I'll be also importing render underscore template which renders HTML file, and also I'll be also using redirect method to redirect the HTML pages, and also request which requests the data from HTML form. So all these methods I'll be importing here, and also I'll be importing JSON to connect with blockchain to read artifacts which are generated. Now here what I'll do is I'll simply create a Flask object, Flask of double underscore name. So this is a Flask application name which I'm going to create. Flask is nothing but which gets data from HTML and passes to Web3. Okay, so you cannot simply pass directly to blockchain. So here we have to create some web application. So here let me show you that def homepage return render underscore template of index.html. So here I'm designing HTML logic. Okay, so if image main, so this is a Python syntax in order to run the server. App.run post equal to 0.0.0 comma port equal to 5000. So this is the Python logic which I'm executing now. So let me go to src folder. Let me write python app.py, python 3 app.py. Then immediately server will be on. Okay, 5000 is not available on my laptop now. I'll write 5001. So let me run app.py. Now you can able to see the Flask server is on. Now let me open that website. So here you could able to see some website is open. Okay, some IP address. Okay, some IP address and website is open now. So on this website is a web application which is running on blockchain. So I have to connect blockchain and this front end application by using Web3 and Truffle. Okay, So here I'm created front end application. So in the front end application, I have created HTML. Okay. So HTML is nothing but it is included with Bootstrap framework. So I have included Bootstrap style sheets and Bootstrap, CDNs, the content delivery network. From the content delivery network, I have imported this Bootstrap min.js, which is a JavaScript file, and jQuery.min.js, and also bootstrap.min.css. Okay, all these files I've taken from the directly internet. Okay, so I've just copy pasted those links, and I'm trying to use those custom classes. Okay, so here what I'll do, I'll create a form, dev class equal to form group, input type equal to text, and name equal to message, and placeholder equal to enter message, and something like this. Okay, if I save this, if I reload this page, immediately you can able to see that HTML box. Okay, oh shit, what is this? Achha, I'm not I've not activated debug. Okay, so I have to activate debug also. Debug equal to true, so that whenever we make any changes, it will be automatically reflecting on the website. Okay, yeah, you can able to see here enter message. Okay, so in the similar way, what I'll do is I'll simply create one more form group, and this form groups are nothing but which, okay, or else I can simply create a form also. Input type equal to button type equal to submit, value equal to store message on blockchain. Okay, or I can write here store message on blockchain, or I can add simply store message. So if I reload this page, you could probably see that button. Okay, so there is enter message and store message. So when you click on store message, this message, whatever the message that you have entered, okay, so whatever the message that you have entered, that has to be stored on the blockchain, that is the target. So for that, we have created some HTML syntaxes in order to create HTML page according to our interest. Now here we have to uh, create a form tag. Okay, so we have to create a form tag, form action equal to slash submit message. So we have to send this data, whatever the data that is entered in this input text box, we have to send to this submit message action, and method equal to post. So I'm using post method now. So this is a HTML form which I'm doing now. This form is nothing but which publishes the data from the HTML to Python. So here we have HTML tags. This HTML tags will help us to read data from user. So user can enter a message, and whenever they click on that button, store message button, immediately it will send that message to this route. So now what we have to do is we have to reload the page, and we have to say hi, hello, what's up, say some message like this, and when you click on store message, immediately it has to send. Okay, so if you see here, it is sending message to submit message. So now it is saying not found because we have not created that. So I just wanted to show you that this particular form. Okay, so this particular form, it is sending message to this API. So now we have to create that API here at the rate app.root, at the rate app.root slash submit message, submit message method equal to methods equal to get comma post. So we have to create a route for that. Def collect message from web application. So let's say message we have to see what is attribute that we have written. So we have written MSG as attribute. So MSG equal to request dot form of message. So that message we have to print message, and we have to return the response. So return printer underscore template of index.html comma res equal to some message like data received. So we have to create some response. Now here, let us create that response somewhere here. Span style equal to color colon green res. So let's create a response on the HTML, so which can communicate from Python. If you have double flower bracket, then immediately it will be communicated on Python. So now what we have to do is we have to reload this page. Okay, so if you reload the page, you can able to see data received. Okay, so whenever you send message, so that message will be published to Python. So in this decentralized application, we are having HTML, and HTML is sending. HTML cannot communicate with a blockchain directly. HTML is sending data to Python, and Python is sending data to Web3. Okay, so Python is sending data to Web3, and Web3 is sending data to smart contract, and smart contract is just appending the message onto the block, and the block is appended to the chain. So this is the process which we have to do. Now the message is getting printed. So the message is getting printed here. If you see here, hello, hi, hello, what's up? So the message is getting printed on terminal, and this particular message we have to store in the blockchain by using Web3 and smart contracts. So now let us do that. So actually we have created one function, right? So we let us copy that function from Web3 import JSON and HTTP provider. So we have to copy this import modules, and also we have to copy this function. So what is this function doing? So this function is connecting with blockchain. Okay, if there is any problem, it will throw you an exception called error connecting with blockchain, but generally this function will help you to connect with blockchain. So this is a 4-stage process. So here also we have to use the same mechanism. So connect with blockchain. So here, whenever the message is collected, we have to connect with blockchain. So contract comma web3 equal to connect with blockchain. So we have to connect with blockchain. So whenever you are connecting with blockchain, you have to provide the wallet address from which wallet address you are connecting. Okay, so here I'll be providing the wallet address. Now I have to call the contract function. So tx underscore hash, because we are inserting data, right? So we have to create a transaction hash contract dot functions dot insert message of MSG, which is nothing but dot transact. So we have to make a transaction call. Then we have to wait until the transaction is completed. So wait for transaction receipt of tx underscore hash, which is nothing but which waits until the transaction is mined. So now here, if you see this application, so what are the message that is received from HTML form? So here we have created HTML, right? So we have created HTML, and that HTML is having one simple form, which is nothing but enter message and store message. So whenever you enter this message, okay, whenever you enter this message, immediately, whenever you click on this button, immediately this particular message will be posted onto blockchain. So here, for example, I say hi, hello, what's up. Whenever you click on the store message, immediately you'll be getting data received. So whenever you get data received, immediately it means block is added. Now if you see, we have block 5. Okay, so this block is now added today. So if you see this block 4, okay, if you see block 4, block 4 is created yesterday at 7:59, but today if you see block 5 is created now, and it is mined at 18:35, which means 6:35, which is just now, because I have added a message on the web application. Okay, so I have given a message on the web application, and that web application is sending data to blockchain. For example, if I publish one more message, So for example, hi, are you sure that we are doing it? Then when you click on store message, immediately you'll get data received. Okay, which means a block is added. Okay, so a block is added. Now block 6 is added. Okay, so now block 6 is holding that message, which is getting mined and which is getting stored in the blockchain. So all that messages, whatever you enter on that application, so that application will be sending messages to, HTML is sending data to Python through Flask, and in the Python it is sending data to Web3. So Web3 is an intermediate software in between Python and smart contracts, and that Web3 is sending data to smart contracts, and smart contracts is doing the job. Smart contracts is just executing it whenever it is required from the whenever the request is raised on the web application. So this web application, if you see, it is running on Ganache, and it's running on uh, Ganache Ethereum blockchain server. Okay, and this data is getting communicated on it. Now in the similar way, we have to see what are the messages that has been stored. So let us create one table. Let us create one container. In body, let us create one container which can distribute the message, which can receive the messages. Container. So here, let us uh, have a for loop. Okay, percentile for I in range of 0 comma L or len, whatever it is, and let us create one table here. Okay, let us create a table. Table is nothing but which displays the messages one by one. Table, and table will have tr. Tr is nothing but table row, th of serial number, and also th of message, the message that is stored in the blockchain, because you cannot decrypt the data on a public blockchain. You need the wallet address, isn't it? So without wallet address, we cannot decrypt the data. So that is why what we're doing is we're just using decentralized application to decrypt the data based on the logins. Generally, in the real-time scenario, you'll have login, register, sign up, and login. But here, for demonstration purposes, I'm using the public wallet address directly. So now, let us have a percentile n for. In between this, let us have a simple tr of dashboard underscore data of I and 0. So what is the message that is being stored? Will get stored here, and what is the serial number, right? Tr of I plus 1. So that is the serial number. It will store the serial number, and also it will store what is the message that is getting stored on the blockchain. So it will be displaying those details here by using a simple table. So initially, let us let us get the data from blockchain. So contract comma web3 equal to connect with blockchain of the wallet address. So we have to write the wallet address, and from that wallet address we have to get the details of the contract. So now we have to call the contract functions, contract dot functions dot view messages. So actually we have written the solidity function, which is nothing but view messages. So view messages is nothing but receiving data. View messages dot call, and this will be storing in some, we have to store in some variable. So let us have msgs equal to. So here we have to write for I in range of len of underscore msgs. So we have to create a list data type, empty list here, to store all these messages, and we have to write dummy equal to square bracket open close. This is also a dummy list which we have to create for every iteration. Dummy dot append of msgs of I, and also data dot append of dummy, so that it will be storing in the global list, and we are transferring that global list to the HTML file. So dashboard underscore data equal to data, and len equal to len of data. So like this, it will be sending data to HTML files. It is L equal to len of data because we have taken a variable called L. Now, if you go back to this HTML file, if you reload the server, you can able to see all the messages. Okay, so these are the messages. Oh shit, where is this index.html? Yeah, we have to create one tr. Okay, table row and then table data. We have to create one table row, and this should be table data. Now, if you reload this page, you could able to see serial number and message. So these are the messages which got stored on the smart contract. Okay, so uh, uh, let us also copy paste it in the second method also. Where is this? Yeah. So this particular logic we have to copy paste here also, so that we could able to get the data after inserting the message directly. Dashboard underscore data equal to data, L equal to len of data. Now if you run this page, okay, if you run this server, now you can able to get this messages. And also, let's say I'll be adding a message. Okay, uh, welcome to day 5. Say this is a message, and say if I click on store message, immediately that message you could able to see here, 6th, which is nothing but welcome to day 5. So which means that this messages whatever you have entered here. Okay, so whatever you have entered here, so that messages are sending to Python, and that Python is sending data to web3, and web3 is sending data to smart contract, and smart contract is sending data to blockchain. Okay, and also the ulta process, like as we discussed. Okay, now who is sending data from whom? So you, for example, you have user. Okay, user is there, user has a message, and he wants to make this transaction on blockchain. Now user will sending data to HTML. Okay, user is sending data to HTML. So a message is a transaction, he is sending the message on HTML, and HTML is just a document language, it cannot do any kind of scripts. So HTML is sending data to Python. So Python is nothing but, here particularly we have Flask framework which gets data from HTML, and this Python is communicating with Web3, and Web3 is communicating with smart contract, and smart contract is communicating with blockchain. So this is the flow. So user has a message and he wants to make the transaction on blockchain network on a decentralized app. So decentralized app is nothing but app which is running on blockchain. Now particularly here, if you see, we have a Ganache which is running on laptop, and user is sending data to HTML. Okay, and HTML is sending data to Python. Python is sending data to Web3, and Web3 is sending data to smart contract, and smart contract is sending data to blockchain. So this is a flow. And if you want message back, say if you want message back, blockchain will send data to smart contract. Smart contract will send data to Web3. Web3 is sending data to Python through Flask, and through Flask it sends data to HTML, and HTML will display data to user. So this is the bidirectional process which happens on the decentralized applications. Now here, if you see, we have data which is getting stored not on database, it is getting stored on directly on distributed ledger. So what are the messages that you type there? So those messages are directly stored on blockchain, and in every block, a message is getting stored, because this particular blockchain we have only migrated one smart contract. So like that, you can migrate multiple smart contracts, you can communicate with those smart contracts by using artifact, and you can create some kind of full stack approach, like you can create some kind of Flask applications or any other application which you like, which can communicate with HTML, and that particular HTML can able to send data to Python, and Python will be sending data to Web3. So it will send data to Web3, and Web3 will communicate with smart contract, and smart contract will be adding information to the block on the blockchain. Okay, this is the flow. Any doubts here so far? Any doubts? Are you all following me? I guess this is bit, programmatically aligned, right? So if you want to understand this, you have to understand uh,
Little bit
how this happened.
fast. Little fast.
Ma'am,
ఫాస్ట్గా ఉంది.
is it bit faster, ma'am? Did I have explained everything fast?
లిటిల్ బిట్ ఫాస్ట్గా ఉంది.
Okay. Okay. Hmm. Okay. Any topic which you have not understood, we can discuss again. So, decentralized application in the sense you have to create everything from scratch and from end to end. So here, if you see, we have created HTML page and we have created app.py. So app.py is nothing but web server which is running and connected to blockchain. And also yesterday we have created Solidity. So Solidity is nothing but the backend part of the application. So yesterday I've shown you how to create smart contracts. So that is the backend. And today I have focused on front end. So in front end, so there is HTML file. So in HTML file, I have created some HTML tags and I have created some kind of input and button. So this input and button. So generally, if you click on the, if you click on the button, immediately that message will be sent to Python by using some Flask approach. So I have created some routes, and this particular routes will be getting data from HTML. So whenever they click on, and immediately this particular routes will be getting the message, will be doing the job. It will be connecting with blockchain, and that blockchain is having some smart contract. So something like in that smart contract is holding some messages also. So that messages are getting stored, and that messages uh, you know we are storing in blockchain on a block, and that block is appended to the chain. Okay, anyways, I'll take one more example so that you can easily link how they are connected. So I'll take one case study from my repository pages so that you guys can able to understand this. Mm, okay, blockchain. Or else some kind of document sharing also I can explain. Okay, let me copy. So let me explain the case study of one project which I've created a bit 1 month back. in decentralized applications, so there will be backend and front end. Okay, so backend is nothing but smart contract. So you'll have a smart contracts on the backend, and front end is nothing but which has HTML and Python. Okay, you can use HTML and Python, or you can use HTML and JavaScript. It's up to you. It's based on the developer. So sometimes people use HTML and JavaScript. Sometimes people use HTML and Python. So here in all my case studies, I have used Python because I'm the Python developer. So I have used Python plus HTML on the front end, or you can use HTML and JavaScript also. So here, if you look at this case study, so there is front end and back end. So back end will be always in contracts folder. Okay, so in contracts folder you will have smart contracts. So that is nothing but back end, and front end is nothing but it will be in src folder. So in src folder you'll have HTML files. Okay, in src folder you'll have HTML files, dashboard.html, index.html. All these are HTML files which stores in templates folder. So this all this templates folder will be connected with app.py. So app.py is nothing but the Python script which I have created for running the entire web application. And this web application backend is nothing but blockchain. So here I have created some contracts, and the contracts are like file and register. So whenever user create an account, so that data will be stored in blockchain. So that data for that storing of data on blockchain, we have created some contract functions like register user. Register user is nothing but storing what is the username and password of the user, and that data is getting stored in the blockchain whenever user create an account and whenever user log in. So whenever people log in into the platform, so I'm just comparing whether it is same or not. If it is same, I'm returning true. If not, I'm returning false. So like this, we have created some smart contract functions. So and also in file.sol, so I have created some contract functions which shares permissions and which removes the permissions, something like Google Doc. Okay, so Google Doc is nothing but whenever a document is shared between the entities, so both entities will be accessing the file at the same time, right? So here also, so we will be also creating document sharing platform where we can share documents to people, and also we can revoke the access whenever it is not required for them. So that kind of feasibility is also there, and we are giving authentication by using public wallet addresses, and we are storing those data in the smart contract, and smart contract is pushing the data onto the blockchain whenever we deploy it. So like this, we have to create smart contracts based on the application scenario. So here in this application, we have created register contract and also file contract. And register contract is helping us to store the login and register details. And file contract will be helping that will be helping us which file, who has that access, how to give access, how to revoke access. So everything is done in the file contract. So like this, we have to create contracts. So and also front end. So decentralized application is nothing but combination of front end and back end. So you should have a front end and you should have a back end. Back end is simply smart contract framework. So you have to create contracts based on the project scenario, based on the business problem. You have to create smart contracts according to it. And front end, so as I said, front end is customizable. You can create front end by using HTML and Python, or HTML and JavaScript. So here, let me migrate the smart contract so that I can show you the output scenarios. So to migrate the smart contract, we have to write truffle space migrate. So whenever you type truffle space migrate, it will be compiling the smart contracts and it will be migrating the smart contracts. So once the smart contracts are migrated, you can able to see transaction hash and block hash also. So what is a block contract address, and everything is getting stored on the blockchain. Okay, so if you come back to the ganache, you could able to see some blocks are being added. Okay, so these are the contract creation of file contract and register contract. So two blocks have been added, and they are nothing but the blocks of register contract and uh, file contract. Now here what we have to do is we have to run the server, the web application server, which is front end server. So there are two servers here. One is Ganache server. Ganache server is nothing but which focus on backend. so which completely focus on smart contracts and backend. And there is a web server which is focusing on front end. So there is front end server and backend server here. Now we have to run the as the Ganache is running, which means backend server is running. Now we have to run the front end server. To run the front end server, so we have to go to src folder and we have to run app.py. Immediately front end server will be running. Okay, so this 5000, I guess we have to change it to 5001. Okay, so on Mac 5000 is allocated to some service. So let us keep 5001 and let us run this server. So now it is running. Now you can open this web application. So here if you see, so this is a web application which I have created. So you'll have wallet address and password, that is nothing but sign up. Now let us go to Ganache and let us have the wallet address. Let us copy the wallet address accounts. Let us copy the wallet address and let us paste it here. And every account should have a wallet address and some password. So here let us have some unique password and let us click on sign up. So whenever you click on sign up immediately, so that details will be stored in the blockchain. So whenever you click on account sign up, immediately you could able to see block 10. Block 10 is added with storing the username and password, storing the data of username and password, which is an encrypted format. Okay, so only smart contract can decrypt this data. Smart contracts will be decrypting the data based on the public wallet address. If you provide the public wallet address, if you give a restrict access, only these people can decode decrypt the data. Then only those people can read the data. What is the data stored in this transaction? The remaining people, they can able to see some encrypted data like this. So that kind of restricted access can also be created by using Solidity and block 10. So block 10 is nothing but, I have created account on the platform, so that data has been stored in block 10. Now I want to log in with that wallet address. So let us have the wallet address and password. Then it will be redirected to the dashboard account. So this is a dashboard account. So this dashboard account is nothing but, a platform which you can upload your documents and where you can able to share your documents with your friends on the blockchain network. So here, for example, if I choose a file, okay, I'll choose a file. Uh, say I choose a file, okay, some file like this. Immediately, if I click on upload, then if I click on upload button, so this particular data, so I have uploaded some data, right? So that data is converted into hash. So that hash is getting stored on the blockchain. And now if you see in blockchain, you can able to see block 11. So block 11 is nothing but that particular data document hash. So whatever the data that is there in the document, so everything will be converted into unique hash value. That unique hash value is getting stored so that no one can tamper the data because the data is encrypted and it is stored on the blockchain network. Okay, so if someone wants to modify it, you should have restricted access. Only the stakeholder, which means the person who is maintaining the network, can able to make some modification. But there also we have to keep some restricted access so that the document will be tamper free. And when the people cannot change the entire document, so we can also create some kind of plugins for that, which can be monitored. So every activity that is being done on the documents will be monitored by this decentralized application. And the decentralized application will be pushing notifications to the peers. So based on that, we can also do some activities monitoring, and we can also understand which one is fake, which one is personal activity. So some kind of integration of machine learning and artificial intelligence comes in picture. So that kind of activities will be predicted by the machine learning and artificial intelligence algorithms. And if the activity is personal, and if it is not fake, immediately those activities can be logged. And if the activities are recognized as fake, immediately those activities will not be stored. And immediately we will be sending alerts to the peer and we will be alerting them, saying that someone is trying to tamper the data and all. So now the file is uploaded. If you click on my documents, you can able to see that So the document which is uploaded to the Ganache. So this particular document we have uploaded onto the Ganache, and every document which you upload will be converted into unique hash value. So this is block 11. So block 11 will be holding some unique hash value now, and if you want to share this document with anyone on the platform, then immediately you should select this share document. Since no one have registered so far, only I have registered on my platform, so that is, it is not showing anything here. So let us log out and log in with the friend's wallet. So let us go to accounts and let us copy this friend's wallet address. Let us paste it here and let us create an account. Let us put a simple password so that we can easily log in. Okay, now let us log in with the first account. Okay, 1, 2, 3, 4. Now I have created 2 accounts on the platform. So every information will be stored on the blockchain. So every information that gets stored on the blockchain on Ganache. Now here, if you see share document, you can able to see some wallet address, because this is the person who have registered on our platform. So to this person, I'm sending this document. Okay, I'm sending this document. I can click on share document immediately. You will get document shared, and that particular data will be also stored in blockchain. Okay, so who has shared the document and to whom they have shared the document and what is the document that is being shared. So all that data will be stored on blockchain. And if the friends log in from their account, say for example, if I log in from the second account, then obviously I can able to, if I log in from the second account, then I can able to see the document from the second account. So here in my documents, I cannot able to see any document because I have not uploaded anything. And my friend documents, if you click on it, then you can able to see the document which I've shared from one first account. So who is that, who has the owner who have sent. So like this, people can able to access the documents, so they can directly open it, and they can they can access the document. Okay, so they can access the document like this, and if you want to revoke it, you can also revoke it. So if you click on logout and if you log in from the first account, there will be a chance of revoking also. People can also revoke it from the first account. Share documents here, if you see, you will have cancel sharing. So when you click on cancel sharing, that permission will be revoked, and this particular data is also stored on blockchain, saying that every activity that you do on decentralized application will be stored on blockchain, so that immediate whenever if there is any problem in the if there is any fault detected, or all this information log can be passed to machine learning, and people can able to do some kind of security predictions, where the request coming from, what type of request it is, whether it is a valid request or not, whether it is a valid transaction or not. Everything can be monitored easily by passing this activity log onto the network. So when you click on cancel sharing, immediately the document will not be shared to your friend, so they cannot able to see the document from their laptop and but the documents will be available on my documents. So this is what the document, every information is getting stored on the blockchain. Okay, so revoke access is stored, given access giving is also stored on blockchain, and every data is getting stored like this. So this is one kind of decentralized application which is running on blockchain. So here front end is HTML, and style sheets have been created by using Bootstrap, and this HTML is sending data to Python, and Python is sending data to smart contracts through Web3. So here, if you see, I've written some hundred lines of program wherein it will try to connect with Web3, and Web3 will be trying to connect with smart contracts, and smart contracts will be connected with blockchain. So the flow is always same. Okay, so HTML will be there. HTML will communicate to Python, and Python will communicate to Web3. Web3 will communicate to smart contract, and smart contract will communicate to blockchain. So though there are different business problems, okay, though there are different business problems, always we have to do the same kind of approach. So HTML, sometimes people use Python, sometimes people use JavaScript. I'll show you one more example by using JavaScript. So I have written some blockchain business. I've created some business problems. Okay, so yeah, NFT marketplace. So this is a business problem which I've created for one client, where I have just used decentralized web application by using HTML and JavaScript. So let me create a folder. Let me clone it. So every decentralized application will have front end and back end. So front end we have to program through HTML, and the connectivity between front end and back end. Sometimes people use, people use Python. Sometimes people use JavaScript. If it is JavaScript, we have to use crypto wallets. Okay, so we have to import crypto wallet. So to import crypto wallet, we have this mnemonic. HDRs have said this. If you want to import the crypto wallet, we should use this mnemonic. Okay, so we have to copy this mnemonic, and we have to open a browser. So crypto wallets are not available on this Safari browser. I'm using Google Chrome. Okay, so I have to change the Ganache to 8545. Okay, or else I'll just click on quick start or new workspace. New workspace server is 8545. If you want to use crypto wallets, you have to use a port number called 8545. Then only this particular crypto wallet. So there is a crypto wallet called MetaMask. Okay, so this MetaMask will be connected. So this is a crypto wallet like PhonePe. I'm unlocking my crypto wallet. Okay, so this is a crypto wallet, and this is a MetaMask. So here, if you see, there are some accounts on MetaMask. Okay, account 1 and account 2 and account 3 also is there. Okay, I'll just remove this account. Okay, so there is account 1. So here, what I have to do is I have to import one account from Ganache. So here, if you see, we have different mainnet. Ethereum mainnet is nothing but the real network. Okay, and we have different test networks like Goerli, Sepolia, Linear Goerli, and all this. These are the test networks. They are the public test networks. If you want to deploy your application to the public test networks, you have to select them. If you want to deploy your application to the mainnet, you have to select mainnet. If not, you have to select localhost. Okay, so now what we have to do is we have to import the wallet. We have to import the account, and Ganache will be having some private key. So using that private key, we have to import an account. So to paste this, and we have to click on import. So thereby you could able to see some balance, 100 ethers of balance on the account. On this account we have 100 ethers of balance. So now if you see this MetaMask, this crypto wallet is now connected with Ganache. Okay, if you select mainnet, so that balance will become 0. Okay, so you cannot use this 100 ethers on any other different network. If you select Go Early or any other network, you will have 0 only. Okay, only in localhost 8545 you will have that 100 ethers. So this 100 ethers, if you want, you can send to any other account in this MetaMask. For example, if I want to send 2 ethers to the first account, my first account is having 0 ethers. If I want to send some money from second account to first account, you can send it. You can click on send, transfer between my accounts to account 1. So say I want to send 2 ethers. Okay, then when I click on next, so this information will be stored on the blockchain again. So when you click on confirm, immediately it will take some time to mine it. Okay, so once it is mined, immediately from 100 ethers. So you can be able to see here the information is mined. So the transaction is mined, and now you could able to see account 2 balance is 97.99 ethers, and account 1 is 2 ethers. Okay, so account 1 is holding 2 ethers. Like this, you can also, like phone pay. Okay, in phone pay, if you want to send money, you can send money from one person to another person. So here also crypto wallets. So crypto wallets is used to send money, receive money. Okay, and it is also used to purchase the real ethers from the main network if you want to. Okay, now this is the crypto wallet. So crypto wallet is nothing but partial node. So if you want to connect with the blockchain application, decentralized application, then obviously decentralized application will be communicating through crypto wallets by using JavaScript. So if you are using JavaScript, you can use MetaMask, and you can create a bridge between JavaScript and MetaMask. For example, I'm using this project. I have taken the business problem, like NFT marketplaces. So you will have a marketplace to sell your NFTs. So let us open it. And again, here also there will be contracts. Okay, so there will be a contract called NFT, and this NFT is nothing but where you will have buy. You can purchase NFTs from the marketplace, and if you want to know who has purchased, then by calling this get buyers, it will be returning the wallet addresses of buyers who has purchased the NFTs. Now, so this is a contract which I've created an SRC folder. In SRC folder, we have index.html. So this index.html is again created with help of Bootstrap. But this index.html is sending data to not to Python. It is sending uh, data to JavaScript. So here instead of web3.py. So yesterday I have installed pip install web3, right? So web3.py or web3.js. Okay, if you want to learn more about web3 is very important. If you want to create any decentralized applications, web3 is important. Either you have to go to web3.js or you have to go to web3.py. Okay, so web3.js is Ethereum JavaScript API, so which is used to connect with smart contracts which are deployed on Ethereum blockchain network. So if you want to communicate with any smart contracts which are deployed on Ethereum blockchain network, then you have to use web3.js or web3.py. If it is through Python, you have to use web3.py. If it is through JavaScript, you have to use web3.js. So web3.js or web3.py both are Ethereum JavaScript APIs. So, and this JavaScript API, it will be trying to help you to connect with smart contracts from HTML pages. So here, if you look back to the program, so here we have Web3 and also truffle contract. So Web3 and truffle contract are the predefined files. I have created app.js. App.js is nothing but the function, the code which I've written to connect with smart contracts based on the application scenario. So let me compile the smart contracts. Let me go to this NFT marketplace and let me compile the smart contracts. So whenever I compile the smart contract, it will be generating the JSON. It will be generating the artifact. So yesterday also we have discussed about it. Truffle migrate. Truffle migrate is nothing but which migrates the smart contract onto the Ganache. So once it is migrated, you can able to access that access that contract from the Ganache directly from MetaMask. So on MetaMask, if you see, we have the Ganache, right? So on MetaMask, Ganache is connected. So this MetaMask can access the smart contract. Okay. Now let me install the node modules, npm install. So it will try to install all the node modules which is required. So this particular project requires a node module called light server. So I'm just installing those modules from by using a command called npm install. So npm install will install all the node modules. So if you are using JavaScript, then node is very popular in the tool in the community. So we have to use a command called npm run dev. Immediately it will start the server. So here if you see, so there are different NFTs here. And let me open it on the Google Chrome because it needs crypto wallet to connect. Now we have this NFT marketplace. We have different NFTs here. we have different NFTs here, and I wanted to say purchase one NFT from this marketplace. So for that, what I have to do is I have to connect this crypto wallet with this platform. So by using this crypto wallet, what I'll do is I'll just connect. I'll connect this site. Uh, I'll connect account to this site so that it will be connected. So you could able to see here connected. So it is now connected with account 2. Now I can purchase any now the account is now the account this MetaMask is now connected with this platform. If I want to purchase this particular NFT, say I'll click on buy, immediately it will send a request to MetaMask. Okay, so MetaMask is having some account which is having public wallet address. So that public wallet address and this particular NFT details will be sent to the Ganache, and on the Ganache they'll get stored that so this particular person with this wallet address has purchased this NFT. So that is what it will be storing on blockchain. So when I click on confirm, immediately you could be able to see sold out. Okay, which means this particular NFT has been sold out to some person on the network by using Ganache. So on Ganache everything will be stored. Okay, so on Ganache all the informations will be stored one by one on the block on the block, and that blocks will be appended to the chain, and every block is having certain transactions. So based on the problem scenario, we have to create those kind of smart contract scenarios. So here if you see, so this particular website is now connected with MetaMask. If you see the flow of decentralized application, so this decentralized application is sending data from HTML. This is programmed in HTML, but HTML is sending data to app.js. Okay, so we have app.js. So HTML is sending data to app.js. App.js is sending data to Web3, to MetaMask. Okay. It is sending data to MetaMask, and MetaMask is sending data to smart contract, and this smart contract is sending data to blockchain. So this is one kind of flow which we have to understand. When you click on this button, immediately it sends a request to MetaMask. Make sure, this is Safari browser, right? On Safari, the MetaMask is not available. So now if you see, if you see here, it is now connected with NFT marketplace portal. And if you click on buy, immediately it will send a request to the MetaMask. And on the MetaMask, if you see, it will be showing you what is the data. Okay. So the function type is buy. It is calling unsigned in 256. And unsigned in 256 is nothing but the ID of this NFT, and that data and the person who is purchasing that will be stored when you click on confirm. So the transaction fee will be deducted from the first account, because that account only we have imported in Ganache, I mean in MetaMask, from the Ganache. So like this, the decentralized application will be working. If you have HTML and JavaScript, then you have to use this kind of approach. If you have HTML and Python, you can go for a programmatical approach directly without MetaMask, without using crypto wallet. Without using crypto wallet, you can directly the what is the benefit of having crypto wallet is that no need to have login and sign up. So because in crypto wallet you'll have the account ID, right? So by using this account ID, you can directly make transactions. But whenever you go for a scenario where you have to create sign up and login for general, in similar to centralized applications. So in centralized applications, you'll have sign up and login, you'll have register and login. So if you want to go for that kind of approach, so I don't think this MetaMask is needed mandatorily, but you can also create MetaMask approach for register and login also, but it is not mandatory. So you can directly connect the HTML with uh, Python, and Python with Web3 with smart contract, and your smart contract will be doing our job as we programmed. Because smart contracts are self-executable program files which are running on blockchain, right? So they're self-executable, and once you call that function, immediately they'll be executing automatically on the blockchain, and the block will be added to the blockchain. Okay. So any questions so far? NPM and NPX. So here we can use any of those commands. Okay, and NPX is generally used for packages which you want to update it again directly from the registry. Then you can go for NPX. Otherwise, say if you want to install any version of the module, then you can go for NPX. And if you want to go for one particular version of module, then you can use npm. So npm and npx both works first both works in the same format. Both commands are used to update the libraries on our laptop. It will try to download and install all the packages onto our laptop. So this is the kind of flow which we have to maintain whenever you're creating decentralized applications, because these days centralized applications are migrating to decentralized applications, right? You can use any of these blockchains. You can use Ethereum blockchain, or you can use Polygon blockchain, or you can use infra blockchain. You can use any kind of blockchain, but people are going for decentralized applications, right? In the decentralized application, you'll have front end and back end. So front end team will be developing it. Back end team is nothing but blockchain team. So people are hiring blockchain developers, smart contract developers on the back end, and they'll be so there is no database inherited here. So there is no database inherited here. So people, instead of database, they can use blockchain, and they can store all the data in the blockchain, and they can able to, because once the data is stored in the blockchain, obviously it is encrypted. And also whenever you go for the ethereum ethereum is a public blockchain, right? You cannot modify the rules of smart contracts, you cannot modify the rules of blockchain. But when companies are trying to invoke their own personal blockchains, they'll be maintaining some specific sort of rules, and they'll be creating smart contracts, so based on the rules which are created internally on all the internal policies that the company maintains. So for them, they'll try to have 2 3 stakeholders which updates all the smart contracts. So based on the business problems and business architecture, they generally have a different perspectives in creating different strategies for the blockchain project. But generally for a broad perspective, so for Ethereum blockchain, anyone can create decentralized applications very easily by using this kind of approach, front end and back end. So back end will be on blockchain, front end will be either on HTML and JavaScript, or HTML and Python. So you can use any of this. But being as a faculty, learning this HTML, JavaScript, Python, you can create architecture. Okay, you can create architecture, and you can push this architecture to your students. And students generally, they'll be going through various programming languages, right? So you can hire some team, you can have some you can be a mentor for your student teams, and if you provide them the architecture, then obviously they'll be building it, right? So there should be some kind of teams, and who will be working on who wants to work on decentralized application, because being as a faculty, it's difficult for you to manage all the programming languages, right? Because in a company also, you'll have front end team and back end team. So front end team will be focusing on one front end part, and back end team will be focusing on back end part. And testing team will be there, they'll be testing the smart contracts, and they'll be testing the functionality of the decentralized application. And there'll be a DevOps team as well. So the DevOps team will be migrating this application onto the cloud platforms, and they'll be also verifying whether this can be done on the cloud or not. So any updations, because people use agile methodologies in the companies whenever they're creating decentralized applications on blockchain. And whenever people follow agile methodologies, then obviously DevOps team has to update every time. So when developers deploy the project update, then obviously this DevOps team has to update it every time regularly. So there'll be different types of teams who are running who creates this decentralized applications on blockchain. It is particularly based on the business problem. You have to understand the architecture part. So what will be, because blockchain life cycle is all about, creating smart contracts, as we discussed yesterday. So we have to create smart contracts, and that smart contracts has to be migrated onto the blockchain network. Sometimes people use local ganache, sometimes people use cloud ganache. Even AWS is also having integration support with ganache, so you can deploy this ganache on AWS cloud platform. Or not only on AWS, you can use Google Cloud or AWS Cloud. You can deploy this Ganesh onto the AWS Cloud and Google Cloud, and you can create a small scale enterprise application on blockchain by connecting all this deployments onto the cloud. And since it is local, if you want to make a transaction, only you can do it, right? So, but whenever you deploy this Ganesh and smart contracts on the blockchain network, so then you will be using multiple feeds, right? So say one person who is maintaining that blockchain will be forking the blockchain network from one cloud machine. The other person who is maintaining the blockchain network will be forking on its virtual machine. So people create different virtual machines at different places, at different countries, and they'll be forking them, and they'll be synchronizing all the distributed ledgers by using consensus algorithms, and they'll be getting updates regularly, and all the decentralized ledger will be shared between all the peers who are maintaining this cloud virtual machine. And once the smart contract is deployed onto that cloud virtual machine, then obviously all this decentralized application will be run on internet machines. So when this decentralized application runs on internet machines, then obviously anyone can access. Like, today we are using Zomato on mobile phone, right? Zomato is connected to Zomato cloud. So there is a cloud virtual machine which is running the Zomato cloud architecture, right? In the similar way, if you could create one kind of decentralized application, so that will be also connected to decentralized cloud. So it is also connected to decentralized virtual machine. So the virtual machines, a small virtual machine can be connected, and they can able to run the entire application process on the cloud. Or else, if you want to deploy, say if you're creating some banking application or banking enterprise application, these days people use private networks instead of public networks. Private networks are getting popular because private networks will be forked, and they'll be modified, and they'll be deployed on their private networks. So when people deploy it on their private networks, obviously there will be a set of stakeholders who will be maintaining them, and they'll be doing all the mining request once the transaction is requested on the blockchain. Okay, so any questions? Any questions? Okay, so I'll drop my repository URL on the chat. Okay, maybe you can try this out. Okay, so this repositories, there are multiple decentralized applications which I've created. Okay, so whenever you see blockchain, then obviously it is a decentralized application. Okay, stock market using blockchain, and plagiarism checker using blockchain, network security, not network security, and a document system, sharing system, blockchain for cyber security. You can look into this, decentralized applications whenever you have time, or you can send this, link to your students, and make them understandable with the decentralized application architecture. And if you ask them to develop such similar scenarios, so they can also develop. So let me share this link. So this is a repository which this is the GitHub profile which I always update my repositories onto it, and every repository which is related to blockchain is updating here only. Okay. So recently I just started this stock market blog using blockchain. I have created some kind of stock markets also by using blockchain. How stock market trading will happen in the similar way. I have created a project called stock market using blockchain. So you can also, so every project will have certain similar architecture. Okay. So if you see stock market using blockchain, it is also having similar architecture. You'll have contracts and you'll have SRC folder. In contracts folder, you have to develop solidity programs. So that is based on the business problem, right? So whatever the business problem you take, so based on that, you have to create smart contracts. And in SRC folder, so there should be a templates folder which is having HTML files, and that HTML files are sending request to app.py, and app.py is sending data to Web3. Web3 is invoking smart contracts, and smart contracts are just updating running on blockchain. So they used to update every information onto the blockchain by appending one block. So like this, there are multiple projects. There are 200, 250 projects will be there. You should have a lot of patience to understand and process things. So any questions? Yep, Ravi Kumarji, you can just comment your question in the chat, okay? So how many of you want to try this decentralized application? If you guys want to try, I can share my email ID and mobile number so that you guys can try if you want to. Everything is there on the I'll also share some YouTube links on emails. Okay, so we have registered data, right? So I'll be sharing some videos as well. Maybe that videos you guys can go through it, because in 2 hours I cannot tell you each and everything which is related to the app. Okay, because there is a prerequisite, like you should able to understand the programming syntaxes, and also you should able to understand the architecture level which is inherited in the decentralized application. If you could understand that, and also based on the business problems, if the business problem is bit complicated, then obviously developing decentralized application will become bit complicated, but the approach is same. Okay, so I'll be using the same kind of approach for any decentralized application that I create on my, on my company. So I'll be following the same kind of approach. Even my architect team is also following the same kind of approach. But generally, we used to do in clouds. Okay, so we will be deploying this Ganache on cloud, and we will be making internet applications related to the decentralized services. Automation tools, it is like, sometimes we use Mocha, sometimes we use because whenever we write programs in full stack approach, so whatever the tools that people use in full stack, the same kind of tools uh, can be used in blockchain technology also. Okay, same test cases can be also created for blockchain technology, because here everything is function calls, right? So smart contract will be holding different contract functions, and by using this Mocha and different automation tools, because generally in the last 3 projects we have used Mocha only. So Sinon Mocha, so we'll be using this automated tools in order to do automation testing on blockchain. Yeah, WebDriver IO can also work. Any other questions? So I'll drop my email ID. Okay. So I guess you have my email ID. My WhatsApp number I'll share. My SIM is not working, but probably you can send a WhatsApp message if you want. Any other questions you have? If no questions, I guess we can wrap up this call. And
Sir, I think
no more. Okay, sir.
Thank you for giving an elaborate session, sir. For elaborately explaining the backend and front end, creating the blockchain using HTML and Python language. Thank you all attendees for attending the program.